Yeah, dog. I'm scared to the last exam. Must put maths in the straight week. I don't know chance. Oh, fine. But yeah, it's fine. If the last week, they don't math must be it's fine. Yeah. That's they're probably gonna make the last exam. They must put 5.
Alright, so trig graph, let's go guys. Okay. So we've got the trig graph. It's a bit difficult when you have 3 weeks off to kind of figure out where the hell you are and where your brain is. Okay. So when sketching trig graphs, remember they give you the domain. Okay, they say you're sketching between 0 and 360. Okay. What are the things you have to remember when you're sketching the graphs? Okay, you're going to go to table mode. Okay, you simply enter the equation, right? Your step, okay, is always going to be what? Cosine, excuse me, cosine cos is 90 degrees. But if there's a number in front of the x, it's 90 divided by that number, right? That's your step. Your step is going to be what you mark off on the x-axis. Remember that?
Yes, sir.
The numbers in front affect the amplitude of the graph. So this was sine x, that was 2 sine x, that was 3 sine x. Okay, so the amplitude has changed. Okay, the amplitude is always a positive value, the absolute value of the coefficient of the sine graph. Okay, so we had all of that. I don't want to get too bogged down. Okay, we'll revise it when we do the other types of graphs. Okay, so this was sine x, 2 sine x, etc. Right, then we did, I think, some revision of other stuff. Go away. Next. Okay, then we had cos x. So this was a graph over here of cos x. 4 cos x had an amplitude of 4. Okay, so the number in front affects 2 things. It affects the range. What's the range of that brown graph? It goes from -4 to 4. Of this graph, it goes from -1 to, and the amplitude be negative, can't be negative, right? The domain is given to you. Okay, this function is changing from a decreasing function to an increasing function. Okay, right, then we had your tan graph. Okay, tan, remember, has asymptotes because it's undefined on the Cartesian plane at 90 and 270. Tan is y over x is 0. Anything divided by 0 is undefined. That's why you get these asymptotes of 90 and 270. When is this graph, by the way, repeating itself? Repeating itself every 180 degrees. The standard sine and cos graph have a period of 360. Tan graph has a period of 180. What's the point you have to remember to mark on the tan graph? It goes with 45 degrees. Okay, the difference is when you enter the calculator, your step for sine and cos is every what? Your step for sine and cos 90, but for tan it's every 45 degrees. Okay, you have to mark this 45 degrees one. Okay, a tan graph is either increasing or decreasing. Okay, this one is strictly increasing all the time. Okay, right. When you do the domain, don't forget to exclude the asymptotes. Okay, then, okay, any graph in the world, if you want to reflect it about the x-axis, what do? What happens to a y-axis? It changes sign. Whatever you do to a point, you do the same thing to an equation, right? So the original equation of y is equal to 2 sine x. But when it folded over the x-axis, it becomes negative y is 2 sine x. So y is negative 2 sine x. So that red graph was the original. I folded it over the x-axis. Okay, that's the graph of y is equal to negative 2 sine x. All right. Okay, and the same thing with tan. If you had tan x, okay, which was the original red graph over there, you fold it over the x-axis, it becomes negative y is tan x, so y is negative tan x. Okay, so that important point will be 45, -1. Then we do that thing. Okay, so how hard you shake the rope, okay, depends on the amplitude of the graph. How often, okay, if you've got a horizontal rope, you shake that rope, okay, affects the frequency. Okay, so the frequency, okay, it's got to match what the period of the graph. Okay, how often it takes to repeat itself. So this brown graph over here repeated itself. That's not a full wavelength. That's a full wavelength. It took 360 degrees to repeat itself, right? Okay, so sorry, all that this graph is showing. Okay, then we had this green graph over here, which also has a period of 360. So all of them are 360. And all I was saying, sorry, the notes there always saying was that the number in front doesn't affect the period of the graph. Okay. And same thing over here, the period of these graphs are 180. But now over here, remember, if you change this number in front of x, so if you had cos x, the period is 360, which is 360 divided by 1. Okay, that's that red graph over here. But the blue graph, okay, if you go, the period of this blue graph, how long does it take to form a wavelength, to do a complete wavelength? Well, there's a 180-degree gap between all the maximums and the minimums, etc., right? You with me? So that blue graph is saying 180 degrees to complete the wavelength. So we say the period of the graph is 180 degrees. From an equation for sine and cos, okay, if we go 360 divided by that number, we get the period of the graph. Okay, so for this green graph over here, okay, it takes 720 degrees to complete a full wavelength. How would you get it from the equation? You go 360 divided by a half. So in general, for a sine and cos graph, the period is going to be 360 divided by that number b, which is the number in front of x. Okay. And then whatever, when we sketch the things though, and this is just showing the same thing for sine. Okay. The step when you draw these graphs, is always going to be what? 90 divided by b. So if you had sine a quarter x, it would be sine a quarter x would be 90 divided by a quarter would be 360. Okay. Sine 3x, the step would be 90 divided by 3, which is 30. That's just, when I talk about step, I'm talking about the calculator, right? Okay, but whatever the step is, that's what you have to mark off every 30 degrees for this one on your x-axis. Fish. Okay, but for tan graphs, if you want to squish them up, normally the period is 180 degrees. So if you had tan 2x like over here, okay, so this was tan x, sorry, this was tan 2x over here. The asymptotes are now at 45, 135, and this graph is now repeating itself, not every 180 degrees, but every 90 degrees. Okay, so if you had tan 2x, the period is 90. How do you get it from the equation? You don't go 360 divided by this number, you go 180 divided by that number. Okay, it's vaguely coming back to you. Okay, the videos are all recorded in the later. Okay, so tan half x, if I gave you that equation, and I asked you to sketch it, well, I asked you what the period was, you'd go, 180 divided by a half, which is 360. If I gave you, so you have to be able to do two things. From the equation, you have to be able to tell the period of the graph, and by looking at the graph. How do I know this period of this red graph is 360 degrees? Well, how long does it take to get from 1 0 to the next 0? It takes 360. Or you can look at the gap between the asymptotes. What's the gap between minus 180 and 180? 360. So it's repeating every 360 degrees. Okay? When you're sketching a tan graph, okay, so in general, the period is 180 divided by b. For a normal tan graph, your step was every 45. So now it's going to be 45 divided by b. So if you're drawing tan half x, and your step on your calculator will be 40 divided by half, which is 90. Tan 2x, 22.5. Fish. Okay, right, then we sketch some of these. Okay, I'm not going to do all of those again. Right. Okay. Now, okay, so it says, okay, vertical shifts of trig graphs. Okay, just stand up for 1 second already. I need to open a window. Stand up, different.
Keep open that window. Yes. The one goes by the stuff. You see that one, not this one. Does it open some the income stream? It's not like for us.
Stand.
Why are we standing? It's all 5 minutes.
You guys are already going into a coma. I can sit. I can tell. All right. Stand.
So it's not break.
You're not going to get a break. You don't stand.
What?
Break wrong, get the person next to you. Okay. Right. Right. Sit. Let's go. Okay. Right. You want to break? We'll have a break in 10 minutes. Right. Version the shifts of trig graphs. Right. Okay. Okay. Right. So now Jen. Okay. Determine the equation of h if h is f of x equal to sine x, shift it 1 unit up. Okay. Right. So, guys, any graph in the world. Third gave you a parabola, and you had y is equal to x squared, and you wanted to move that 1 unit up, won't we? What is the new equation be? There we go, side. No, I've got y is equal to x squared. Okay. I like when people start to speak and they have no idea what even the question was. Okay, and I want to move this. Listen here, now, then if I've got y is equal to x squared, and I want to move it 1 unit up, what's all the new equation be? Thank you, Taylor. Right, okay, y is equal to x squared plus 1. And it'll move the graph 1 up. Okay, if I wanted to move that, then add 3 down, what would the equation be?
You put the minus. Yeah,
Like so.
Yeah.
And what will happen?
then you'll go down.
Lie that down here, right? Okay. So to cause the graph to shift, we simply add a number to the end of the equation, right? Okay. So if you took f of x is equal to sine x, what I said, and you shifted it 1 up, what's it going to become? Okay, they said give it the name h. So now they've drawn sine x for you. So without using your calculator, okay, go draw the graph of sine x plus 1. What do you simply have to do? Take your main points. That's sine x. Take those points and go move them once. 1 unit up. Okay. So if I move it 1 up, okay, there, up. Okay. And there's a graph of h of x is equal to sine x plus 1. Okay. Now, see. Okay. Now, just to show you that if you're doing it from scratch, okay, it says using a table function in your calculator. Okay. So it would be easier. What's the quickest way to do this? To just take these points and move them 3 down, right? Okay, that'll be the quickest way if you're given this graph. But if you're drawing it from scratch and you wanted to refine x minus 3, I just want to show you get the same thing. On your calculator, what are you going to do? Okay, so go to your calculator, right? Come on, here's your calculator. Okay. You can borrow mine.
Because they probably put it.
Okay, right. All right. So now, go. Okay. Go mode. Okay. Table. Okay. What do you enter? Come on, do it. Okay. Enter the equation, right? So you're going to enter f of x equal to sine x minus 3. Okay. Right. So what's the start? 0. What's the end? Okay, they always tell you the start and the end, right? Now the step, will the step have changed? No, it hasn't been squished. Okay, the number in front of x is still just 1. So your step is still just 9. Enter that into your calculator and just put out the points. Any notes? Did you get any fair other notes? Minus 3? Yeah, other notes.
Mr. Taylor, what?
What was this key?
Optional.
Okay.
I win.
What?
I saw win.
Yeah, more notes. No.
No, it's in the. So then I'll ask the question. That's really good. Exactly. But with that last taste I gave you, a book with my thing.
Yes, I've got all of that. So I must get that to you. Right. We'll add them out now. Okay, right. So, now we answer those questions. So the graph, okay, is going to look like this. It's going to go minus 3. And that, the calculator should give me those points. Okay. Okay, so this point here would be 90 degrees and minus 2. Okay. This would be 9. It would be 270 and minus 4. Right, so guys, let's have a look here. It's very important when you find equations of graphs. Okay. If you look at this graph, sine x plus 1, what I'm going to tell you to do when you're finding the equation is draw in the middle line. Right? So it's like we had a rope, we lifted it up, okay, and then we put the wave into the graph, into the rope, right? The new middle line is always happy that that's the middle line. And there's the same amount above as there is below. How much from there to there? 1 up. How much from there to there? 1 down, right? So that's your new middle line. So whatever the new middle line is, that's going to be the vertical shift. Okay, so over here, where's your middle line? That's minus 3. Whatever that is, if you're asked to find an equation, that's going to be how much the graph has shifted, whatever that new middle line is. Okay. Right, let's go on to the questions about that graph. What's the range of H is the green graph? The amplitude of P was the last graph we did, eh? That's P. And the period of F, which is the rest graph. Yeah, you guys have a great speech.
My books was in the locker. What can you do? Go fetch it. Oh, I was also allowed to go fetch it.
Okay, right. So what's the range of H, guys? Where does H go from? What is range? X or Y values? Y. So Y is an element of. What's the smallest Y value on the? No?
0.
0. There's the smallest Y value, right? So the range goes from 0 up to 2, right? If I said to you, what's the range of the blue graph, it would be from -4 to -2, right? Okay, but the green graph is a range from 0 to 2. Try the next two. What is the amplitude of P? And what is the period of F? Okay, so what's the amplitude of P? Simple. P is the blue graph. So the amplitude is the distance from your middle line, okay, to the minimum. What's that distance, guys? This was -3, this is -2, that's -4. You're traveling 1 unit. All of these graphs have got the same amplitude. Okay, all of the graphs. Okay, the difference, the amplitude hasn't changed. Why hasn't the amplitude changed? Because the number in front hasn't changed. You with me? So all of these graphs have the same amplitude. They have an amplitude of 1. To make a note, this is the same for all. And have the periods of the graph changed? Has it been squished or stretched out? No. Periods are still the same. The period is equal to simply it's taking 360 degrees to complete the full wavelength. Okay, we'll go for 5 minutes and we'll have a single break. Okay. Yes, done. Okay.
Set the timer for 5 minutes.
Actually, don't. Right. Okay. So, vertical shifts are the same. Okay, so this is not difficult stuff. Okay, now you've got the graph of tan x, and they say what will be the equation? It's just 2 units down.
Should we make it H of H?
Okay, and they say give it the name H, yeah. So to determine the equation of H from page 13, if f of x is tan x, just the 2 units down. So Kiki, what's that going to be? That's good. Tan x minus 2. And remember the right hand side there, just pop. Black. The F for the Last image was in there. Not really. Alright. So now, using f as your base, sketch h of x is tan x minus 2. So what are you simply going to do? You're going to move everything 2 units down. So I'm getting here your asymptotes. Your asymptotes are not going to be affected. Okay. They're going forever up and down. Okay. Which will be devastating for all of you.
Why? No, please don't leave.
No, I said I'm going to lose my voice. Okay. My voice is gone. I won't. Right. Okay. I wouldn't give you that pleasure. Right. Okay. So now, the important points were what on the original graph? What are the important points on the tan graph? 45 and 1. Okay. And 225. I mean, you can put 135 and negative 1, right? You have to label them all. 180, right? So those are your important points. What are you going to do to all of those points? Shift them 2 units down. Hello? I have to put this. So you and put a huge stop on this. Hold on. Okay. The bull has them, the cow doesn't.
Oh.
Okay, right. So 45 1 is going to become what? 45. What are we doing? 10x minus 2. 45. That's naught. That's going to go down to minus 2. Okay. This is going to go down to minus 1. So that's going to become 45 minus 1. I would label that 45 minus 1. Right? Hang off. So that will be your first part. You with me? Okay. You can't keep these points at the end and make them look like they're 2 units down because perspective is impossible there. Okay. Here, 180 is going to go down to minus 2. This is going to go down to minus 3. This point is going to go down to minus 1. So the graph is going to do that. Okay, in fact, so asymptote like mine did there. Are you with me, guys?
Yes, good.
Okay. Then this has gone 2 down. This has gone 2 down. I'm marking it. I've marked that that point is labeled, that point is correct. Okay, and then your general shape. That's that. Okay. And just to quickly check, okay, if you're drawing this on a table function, tan x plus 1, okay, just pretend you haven't got a tan graph. If I just said you sketch this graph, okay, what would your start be? Naught. I should say tan x plus 1, they should say in the question x is an element of naught 360. So start is naught, n 360, step is what? 25. Just check you get the points. But really, it's just the main points from the red graph move 1 up. And it's quite weird because you're going to see in the questions later, nothing in terms of your parameters actually change. Remember, a tan graph doesn't have an amplitude. Okay? And the range of any tan graph is always the same, even if you've done a vertical shift. Okay, let's finish this. Okay, so if I enter that onto your calculator, tan x plus 1, you should see that you get these points. Every point just compared to the red graph has gone 1 up. So that'll be 1. That will now be 45, 2. That'll go like that. This point will go to 0, that'll go to 1, that'll go to 2. Okay. And this point will go 1 up, that'll go 1 up. So you're going to get your blue graph. That'll be f of x. I mean, this will be the graph of what do we call this? P of x. The P of x is the blue graph. Yeah. Okay. So then just quickly, okay. Have the ranges changed of any of these graphs, right? No, even though they've gone 1 up, they still go down to negative infinity and up to infinity, right? So you can say the range of all of them, okay, is y is an element of reals. Has the period changed by adding a number to the end? No, the period is still just what? No, the step is 45, the period is 180, right? Remember the tan graph with the period of 180, repeating every 180.
So
So the only thing that's really changed is what goes with 45, the steepness scale. Yeah. Yeah, always.
So do we pretend that y can't be equal to 90?
No, x can't be 90. So if they say you want the domain,
Okay.
you'd say x and element of north 360x, but y can be anything.
So why is it period 180?
Why is it?
180.
The period of the graph.
Yeah.
Because this graph is repeating all tan graphs repeat every 180 unless there's a number in front of the x. Because how long does it take to complete a full wavelength? Or how often does it take to repeat? What's the gap between 90 and 270? 180. If you look at the zeros, 0, 180, every point is repeating every 180. Right. You have a break, but I want everybody to move. Okay. I'm coming back to school, you know, school first. Okay.
Oh, this one. Okay.
Sorry.
Okay. So it's okay now. What's this? It's fine. Oh. The final dress that you got, I don't know if the dress is gonna come in time. I'm curious. Yeah.
Right, let's go. Let's go. Come. It'll take you a minute to get you there.
No.
Two days. Otherwise, we traffic.
They can actually just show each of me stomach crawling under the mind. Fine.
Right, it's not very bad.
Oh, but now the doors are open. Oh, right.
You should have a vodka. But stop playing, I'm being important. Each generation. Hey, man.
Just don't take the top of the pot.
Okay.
Don't take the top
What
of
about you?
I know you took from the middle.
Right. Calculator out. Let's go try to get to thing. Okay. So on your calculator. Right, let's have a look. So if you are asked to sketch negative sine to x plus y between 0 and 360. Okay? Okay, we're going to sketch on the thing. We're on page 14. Okay. Okay, right. Okay, so what's the start? Well, they tell you where to draw it between, right? Before you, so start is 0, end is 360. What's the step? Careful. Why? Because of this 2, right? So your step is 90 divided by 2, which is 45. This graph is going to have been compressed by a ratio of 2, right? So your step is 45. It's this number over here that affects it, right? So what are you going to mark off on your y-axis? Well, it's going up in ones really. Okay. So every 1 on your y-axis, okay, up to 4. Sorry, I mean that should be x-axis. So on your x-axis, you're going to mark off every 45. Okay, we're not going to often give you that actually, guys. So whatever your step is, that's what you need to go mark off. Okay. Right? That's when something important is going to happen. And by important, I mean a maximum, a minimum, or a 0, right? And your y values must go from, don't worry about this too much, you'll see your calculator will spit that out for you. Okay, but they are going to go from sine, a normal sine graph has gone 1 up, so it's going to go up to 2 and go down to 0. Okay, but you don't know that. Let's put it over here. The calculator will tell you that when you put it in stable mode. Yeah.
Divided 90 by 2 is
The sine 2x. If there's a number in front of that,
divided by the number.
that number in front of the x.
Divide.
So if I gave you this, y is equal to 4 sine 3x. What's your step going to be? No. 90 divided by that number over there, right? This affects the amplitude. This affects the squishiness. Okay, the 3 affects how much it's compressed. Okay. So your value step would be 30 degrees. Okay. That's all right, man. Okay.
Those movements of the day.
I'm sorry for tomorrow. Tomorrow I start.
Did you give yourself like a 3
I gave myself, I stopped Duolingo for 6 weeks. I'm a basic limits. But I went back, but I have to write things down as well. Duolingo learning is more than that.
Why?
I know, it should.
Make it in the next segment. Very serious. I the amount of times I was sleeping, I was sleeping. It's I was going to
But sometimes it's why is like the language you want to Huh?
Thank you.
You use a lot, eh?
I think you realize like it's, but also.
More people speak of regards to think like in the cave. I mean.
I know, but also not their times.
All right, let's roll this quickly. Okay. So, let me see if I can draw this out of concept. It will be naught one, eh? Then it will be 45 naught. Am I right?
Yeah.
Okay. And then it must go like that, carry on in that pattern. Feel like it there, guys, by the way. Got the first 2 points. And it just keeps going about the middle line of one, so it goes up, there. All right?
Oh, so it was 145 2.
But no, but it's negative sign to it. You enter sign to it.
Yes.
All right. Are you sure about that?
Yeah.
So you enter negative sign 2x plus 1.
Oh, just like that. No,
Yeah.
you're right. Oh, but you know you actually didn't go.
So sorry. Okay. And this is the graph. Okay. But do you see that, guys? You got the first 2 points. You can actually complete the graph very easily without even looking at your calculator. Because it always goes 0. In other words, along the middle line. Minimum 0, maximum 0, minimum 0, maximum 0. Yeah. Can I try to answer the questions about that graph, guys?
These questions, they can read when I think.
Give me a name about the next 3 questions underneath.
Did you get the next 3 questions?
What did you get for the range of this one?
Yes.
Good. Not agree. Y goes from 0 to 2. You agree? Smallest Y value is 0, biggest Y value is 2. So what's the period of the clock? Now that's the step. Okay, don't confuse the period with the step. The period is how long it takes to complete a wavelength. Check with your neighbor. What's the period of the graph? It's not 45. It's not 360.
100.
Okay. So look here, guys. Don't just shout out numbers. Okay. If I look at the maximum, how long from one maximum to the next? What's that distance? That's 180. So you can look at it like that. You can also say, how far does it take to complete a full wavelength? Well, that's half a wavelength. A full wavelength takes 180 degrees, right? Okay. So the period of the graph is 180, right? You should also just use the equation. If I use the equation, okay. How do I use the equation? Well, I've got sine 2x, right? So if you got sine 2x, okay, your period is always equal to Okay. Your period is equal to what? 360 divided by this number. But you should be able to see it from a graph, and you should be able to see it from the equation. Okay. Somebody got a question, Rambo?
Like the distance between the intersections, like.
No. Okay, yes, well, yes, in this case you can. Okay, the distance from there to there is 45, yeah. So what you're really doing is, in this case, what you're doing is actually looking, in this case, the distance between the intercepts is the distance between the minimums. So I would either look at the distance between the minimums or the distance between the maximums. Okay, the minimums happen to be x-intercepts. Okay. And what the domain, guys? If I start drawing the next one, domain is x is an element of 0, they give it to you in the question. X is the element of 0.
So will they give it to us?
So they have to give you the domain, guys. Okay, in the question. This graph goes on forever. Okay, they give you the domain. Okay. They tell you where it's going to be. The only thing you have to remember with the domain is for tan graphs, you're going to have asymptote. So you're going to have to write x cannot be equal to such. Right, now you've got 3 cos x minus 1. Okay, and you've got to draw it between 0 and 360. So go to the start, the end, and the step. Yeah.
Okay, we'll do step. Okay.
Start is 1. Anyone starts.
0.
The end is? Okay. The step is what? No, what's the number in 3 cos x minus 1? What's the number, the silent number in front of x? It's 1, right? 360 divided by 1 is 360.
So 90.
Okay, so your step is 90. So you're going to mark off every 90 on your x-axis. Don't worry about the next one. So just go enter 3 cos x minus 1 in your calculator. Okay, good. Let's just roll this. We want to answer the question. What's the first point? X is not. It's 2, eh? Okay. And at 90 you get -1. Okay, perfect. Thank you. And I'll go back to 2. Then go up to 4. Am I right?
So that's a -4.
Yeah, me too.
What?
180.
Sorry. Thank you. So just for me again, Nene. 90 what? -1. Then 180 -4.
Yes.
270 -1. 362. Now, guys, when you draw this, okay, I don't know how penalized you don't do this, but really remember, it doesn't just look like a parabola. Okay, it starts flat, gets steeper through the middle, becomes flatter again, gets steeper through the middle, and becomes flat towards the top. All right, guys.
Oh, it's gonna be y values from good -4.
From 2 to -4.
Yeah, that's what I mean.
Okay, and the range goes from what, guys? -4 to, always starts with a more -1. The period is 360. The domain is x goes from 0 to 360. The minimum value is -4. It's the smallest y value. Thanks, guys.
Big view here.
Cheers.
Was the block streets and then it's done, you see the. What? So, yes. My dad has all of them.